Welcome back, everybody, to another EdgeX Foundry Tech Talk. We are joined again this week by Jim White, who is a distinguished engineer and lead of the IoT platform development at Dell. He's also the founding architect of the EdgeX Foundry project and currently the vice chair of our technical steering committee. This week, he's going to be walking us through the EdgeX APIs. You can follow along with us here, and we also have similar documentation on our docs website, docs.edgexfoundry.org. At the end of the presentation, we should have some time for some questions and answers. So if you think of anything during the presentation you want to ask, at the end of this, you can join on the microphone or in the chat that's here in Zoom, ask your questions, and we will answer them to the best of our ability. And this recording, like all the other Tech Talks, will be available to watch later on. We will update our wiki page once those links are available. All right, and with that, I will hand it over to Jim.
Thank you, Michael, and good afternoon, good evening, good morning to all who are joining us here. This week's Tech Talk is going to be about an API walkthrough. Michael already introduced me. Thanks, Michael. And for those who don't know, Michael is our EdgeX developer advocate. You can reach him through Rocket Chat or our email channels that are available on our EdgeX website. And I highly encourage you to take advantage of that resource. Michael serves as a great mechanism to communicate with all of you in our community to help you get on board, help answer questions, and help direct you to the right resource inside of EdgeX where you do have a problem that goes beyond what's in our websites. Our Tech Talks, we try to provide these to, we say new community members, but it might be people who are trying to catch back up as well, getting an update. And you'll find, as Michael said, out on our wiki site, a link to the Tech Talks that have occurred in the past, as well as information about those that are coming up in the future. In fact, we'll have a few minutes here at the end of our discussion today to chat about any potential topics you would like to see. We would welcome anybody's feedback there about areas that they'd like us to explore as part of these Tech Talks in the future. Our agenda today, it's about taking a look at this thing we call the API walkthrough. I'll help define that and orient you around what the API walkthrough is all about. We'll then go through the walkthrough kind of in a step-by-step fashion so that as you do this on your own, or if you take the API walkthrough and start to extend a bit into other areas of EdgeX, you'll have a little bit of an understanding about how it works, and you can use the recording of this particular presentation to help you out as well. We also have a lot of documentation and Postman support. We'll talk about what Postman is coming up to help you with this walkthrough. So we'll talk about that as you go off and do some of this work on your own and maybe go through the walkthrough on your own. You'll have plenty of help to guide you through it beyond just this Tech Talk today. And as I mentioned, we'll talk about future topics of this forum, as well as trying to answer any questions you might have. Not only about the API walkthrough, but we'll try and answer any questions you might have about EdgeX in general. With that, why do we have this demonstration API walkthrough? Well, as we were putting together EdgeX, it is a system that has many pieces to it. For those of you who are not yet familiar with EdgeX, there are several microservices that make up EdgeX. If you will, think about a dozen or so mini applications that all work together to provide this IoT platform. And because of that, it does make the system very, very flexible, but it also can lead to some complexity, trying to understand how all the pieces fit together and how they work together to provide an IoT solution can sometimes be lost forest through all the trees. So we built this walkthrough to try to help you get a little bit of a handle on how EdgeX handles data coming up from a sensor and how it gets ingested into our database and then made available to things like cloud systems. We say cloud here as in Azure IoT or Google IoT or AWS, but in reality, it's how we get data to almost any enterprise or back-end system to include clouds. We also look at how you actually actuate devices. So if you have some sort of sensor or devices connected to EdgeX, getting data from that particular device or sensor is half the job. Being able to command back down and what we call actuate that device is the other half of what EdgeX facilitates. And just in general, how does the job of dealing with the edge, dealing with sensors and devices, dealing with all the data in the control plane that is a IoT system, how does that work? And how does that work with regard to the APIs that are in all these microservices of EdgeX? So this walkthrough is meant to kind of get you that orientation around the facilities of the microservices and how they all work. In particular, too, we look at how the provisioning of a new device happens with regard to two particular systems, and that is our device services and things we call devices as far as EdgeX is concerned. Now, a lot of this work actually happens behind the scenes in that in most cases, the device service and the device communicate with each other and get themselves established with EdgeX. But as somebody who's developing with EdgeX or somebody who might be using EdgeX, it's always helpful to understand exactly what's going on behind the scenes and how a new device comes into existence with regard to EdgeX. And the API walkthrough will actually help us to see that. And lastly, we're going to give you a mechanism here to actually allow you as a developer or a user to manually trigger the APIs in EdgeX. That's really helpful from several perspectives. If you're debugging the system, being able to trigger an API allows you to kind of step through what's happening. It also allows you to start to see data flow from one microservice to another. And if you've got some sort of Wireshark or something watching the data flow between services, that can be very, very helpful. And just in general, get an understanding of how EdgeX reacts to any particular API call you make. You hit an API here and something else happens over there. It's important to be able to see that. And so through today's walkthrough, hopefully you'll get an appreciation of that and what's happening behind the scenes in all of that data flying around the system. So that's why we created this demonstration API walkthrough. And to give you a little bit of a pictorial about what's going to happen here in this walkthrough, I've got the classic EdgeX Foundry architectural diagram up here. And essentially, we're going to start by first getting a device and a device service set up, or if you will, initialized, or another term to use would be provisioned in this system. So we'll get those set up. And in particular, we're going to provision a camera device that watches, say, for example, a street corner and counts the number of people and counts the number of dogs. Now, this is a fictitious device as we're just trying to exercise the API, but we'll see how you would bring on that particular device and what happens again underneath the covers as EdgeX operates to facilitate devices like this in the real world. And once we've got that particular device provisioned or set up in EdgeX, we're going to see it push data up through things like core data, push data up into things like our distribution service, and make it available to push out to the cloud. We're going to see how you actually trigger data through core data. As if you were a device, we're going to actually play the role of the device itself and actually push data in through the system and watch it fly through all these various APIs. But we're also going to play the role of EdgeX in actually making commands that get pushed back down to the device. In particular, we're going to see how we would set the scan depth of a particular camera. Again, this is a fictitious device, but the idea is the API could actually trigger a real-world device once you had something actually connected to EdgeX. And with all this, we'll also see a lot of the other pieces and parts that go along with EdgeX. For example, we'll see some APIs around things like logging and how client registration occurs to get new distribution services set up. So again, kind of a complete overhaul of the API, or at least a slice that would be regarded as an overhaul of the API to understand from top to bottom how the devices and data coming up from devices is manifested through to the enterprises and cloud systems, and how actuation devices through EdgeX occurs. Now, a couple items to note here in doing this walkthrough. When you want to go and run this API walkthrough, you will need to do some work to set up your own systems to be able to exercise these APIs. First and foremost, you're going to need to get and set up Docker and Docker Compose. Now, if you're a fan of our Tech Talks, if you go back to the Tech Talk link, you'll find in the last Tech Talk, we actually provided a presentation about exactly that, how to get EdgeX and how to set up Docker and Docker Compose to actually run EdgeX. So step number one will be you'll have to actually get Docker and Docker Compose set up. Step number two will be to get and run EdgeX microservices in the Docker Compose way. And again, the last Tech Talk addresses these two items. These are not going to be items that we're going to cover today any length. I'll show you that EdgeX is actually up and running via Docker and Docker Compose, but beyond that, I'm not going to cover the basics of how to get EdgeX and how to get it running in Docker and Docker Compose today. The next thing is you're going to need some sort of REST client tool or REST API tool. In other words, you need to be able to execute REST calls. So you need to be able to perform gets and posts and deletes all through REST. You could use a browser in some cases, but typically browsers, at least most of the browsers you and I would use to surf the web, are really only going to help you make what we call get calls in REST. And we are going to be doing several calls here through the walkthrough that actually require post and things like delete and puts. So in that case, a simple browser typically is not going to facilitate your exercise of the API walkthrough. Unless you've got a browser with some extensions or some add-ons built in, you're not going to be able to do things like put, post, and delete. So you're going to want to get an API tool out there to allow you to execute these REST calls. One that we highly recommend, and many of us in the EdgeX project use, is a tool called Postman. And you can actually find this tool at getpostman.com. Again, this is not a setup process that I'm going to take you through today. You will actually see Postman executing the call, so you'll actually see what Postman looks like. And for those who do use Postman, I'm going to provide you a link at the end that allows you to upload all the API calls I'm making in our walkthrough very easily into Postman with kind of a prearranged set of facilities built specifically for Postman to do our walkthrough. So in other words, if you're using Postman, doing our walkthrough has actually been made very, very simple for you. And we'll talk about that at the conclusion of our talk today. So that's the setup work on you. That's the setup work. If you want to actually do this walkthrough that you see today on your own, then you'll need to do these setup processes before we actually go through the walkthrough. Some context now about the actual walkthrough. As I mentioned, we're going to play the part here of an IoT camera. In other words, we're going to set up through EdgeX a new device, an IoT camera device, and it's going to be one that actually counts people and dogs. In other words, it takes a picture, say, for example, of a street corner, and detects the number of people or humans and the number of canines in that image. Now, that may actually sound like a kind of a funny use case or a funny extension of IoT, but in fact, such a camera actually does exist. Analog devices actually provide something they call the Blip2 camera. And that camera has intelligence built right into the device to be able to do just that. Count the number of people it sees, and or it can be made to count other things like dogs or cars or things of that nature. So if you're interested in this kind of device, Google analog devices Blip2, and you'll actually find this particular apparatus out there. So we're not going to actually have that device attached today. In a demo like this, I couldn't really make that work anyways, but in this demonstration, we're going to see how something like an IoT camera would actually be provisioned into the system with the API calls into things like device services, and then how an IoT camera would start to report that data into EdgeX in a typical fashion. Now, we would have to assume that someone has already created the device service to interface with EdgeX. In other words, as we look at all of the microservices that make up EdgeX, one of the pieces that we leave for the developer community to help fulfill is the piece that actually interfaces with the hardware, with the actual sensor or device. And we're going to make the assumption that somebody out there has actually created a device service to do that, to interface this IoT camera with EdgeX. Once that's accomplished, though, we will see how we get the camera set up and provisioned in EdgeX, as I mentioned. We'll actually see the camera reporting a count of people. In fact, we'll manually trigger that with our own API calls. And then we'll see how EdgeX handles that data coming in and how it gets it to things like the cloud or the enterprise, what we call exporting of that data. And we'll see how EdgeX would actually actuate back down to the device. Say, for example, if somebody wanted to trigger what's called the scan depth, or how far out the camera looks, we'll actually see what something like that API would look like. Again, we don't have a real device, but if that device was attached and if this API was called, the camera would actually be able to set or refocus itself to be able to look at a street corner in a slightly different way. So the walkthrough explores these questions along with some others, as we'll talk about. Again, things like, well, how would I actually look at things like logs? Or how would I know that the cloud that I've wanted has actually physically been registered to receive this kind of data? We'll look at some of that as well in this API walkthrough. So with that, we are ready to actually do a step-by-step walkthrough of the EdgeX API. Let me get this screen out of the way. So move my PowerPoint slides out of the way. Let me first bring up just a terminal window, and Let me make sure you all can see that pretty well. Yep. And I'll clear the screen here. What I've got here is just a terminal window. I've got EdgeX actually running on an instance in AWS right now. Since we don't really physically have sensors or devices connected, we'll just run it up there in the cloud and pretend like this is on a gateway or some device local to us. And as I mentioned, you would have to get Docker and Docker Compose loaded up in your particular environment where you're going to run EdgeX. And then you would have to pull down the Docker Compose file to get EdgeX. And then you would actually have to run EdgeX. And so if we take a look right now, and if I do a Docker Compose PS, we'll actually see the EdgeX microservices are all up and running. So we've got an instance of EdgeX running, in this case again in AWS, but pretend like it's on a gateway. And it's ready to set up and run new devices, or if you will, manage new devices, and start collecting the data off of those devices. And in fact, proof positive of that, I'll bring onto the screen now. This is our registration configuration service provided by Console. And if I go out to my instance that's running EdgeX in the cloud and I hit port 8500, we can actually see that Console is giving us an indication that all services are up and running and all the statuses of those services are green, meaning things are good to go. And this is a test that's kind of part of that getting EdgeX up and running. That was part of our first tech talk too. So if you're confused by what I'm showing you at this point, again, I encourage you to go look at how you get EdgeX up and running in that first tech talk. And it'll actually take you through what Console does to actually display the services up and running here. So very good. We have EdgeX up and running. Now let's go start to exercise the actual walkthrough. This is a demonstration that is actually available online at our docs.edgexfoundry.org. If you go out to the EdgeX documentation, Michael has done a wonderful job of organizing our documents now, and we've got this EdgeX demonstration API walkthrough that's right there on the front page of our documentation. So this is the API walkthrough that I'm actually going to step-by-step go through with you today, and includes instructions about how to get your environment set up and actually running EdgeX. Again, those will be steps that we'll skip. And then there's actually some discussion too about this camera use case and what the idea is that we're trying to portray, or the context, if you will, that we're trying to portray by showing this API walkthrough today. So from that, we're ready now to go ahead and start to step through the actual API. So with that, let me bring up Postman. Postman is a tool, again, that is very, very helpful to developers to actually exercise all sorts of REST APIs. And in this case, to exercise our EdgeX APIs from device services all the way up through to our export services. So I'm going to slowly take you through the APIs here. And if you've never had any orientation through EdgeX, some of this may be a little bit foreign, but go ahead and start to spin yourself up on EdgeX and come back to this walkthrough and the recording of this walkthrough, and hopefully it'll start to make a great deal more sense. So the very first thing we have to do with regard to EdgeX is we have to make sure that the actual device that we have available is provisioned in and understood by EdgeX. One of the things we have to do as part of that is actually make EdgeX aware about exactly where is this particular device. In this case, presuming that it's some sort of IP addressable type of address, IP addressable type of device, we want to give that information to EdgeX. In other words, we want to give the address of that camera and the camera control, meaning the device service, to EdgeX. We do that with a call to what is known as the addressable API in EdgeX. So in this particular case, we're going to make a call into metadata. Metadata is by default at port 48081. And the API calls API version 1. We're going to call to addressable, and we're going to make a post. And what, in fact, we're going to post is that we have a new camera control, meaning that we have a new device service that's going to control these cameras. And we provide information about where this particular device service is going to be running. We're going to provide a fake address here, folks, because we're not really running this device service today. We're going to play the role of the device service, but we would provide information about where the device service is located, what port it's at, the path to get to the camera control, all the details necessary to actually communicate with that particular device service. We call that an addressable, if you will, something that is IP reachable in our EdgeX world. So that's our very first job, is to set up the location, if you will, of this service. So you will notice in terms of my API call here that there is a host, obviously, that has to be provided. The nice thing about Postman is it provides a means to actually set up some of these parameters and allow them to be reused. So in this case, I'm using an API walkthrough environment. And if we go to that API walkthrough environment, we'll see that the environment includes a host address. And this is actually the IP address right now of my AW instance. So that is something you'll have to change for your environment, is to point it to the particular host, or in other words, include as part of your API walkthrough the location of your EdgeX instance or your EdgeX host. Great, so let's make that very first call in our API walkthrough to get the device service for the camera set up and as an addressable. So I'll make that post, and what we see come back from almost all of these APIs as an indication of success is a status code 200, as well as the actual identifier of this new addressable. In this case, a big long GUID, 5BA, et cetera, is an indication that that addressable was set up. Now we want to set up a new addressable for the actual camera itself. In other words, the camera is IP reachable. How do we reach that? We'll make a new call to the addressable API. And in this case, we're talking about the actual camera address, not the device service controlling the camera, but the actual camera address. Again, providing its protocol address, how we reach it, what its path are, whatever the particular parameters are to speak to that particular camera are necessary as part of our addressable, are put inside the body of our post request to create this addressable. And again, I'll make that request. And again, we see a status code 200 and the actual identifier come back from EdgeX, suggesting it now knows how to talk to, or at least where this camera is located. So now I've added two addressables, but I haven't added the device. I haven't added the actual device service yet. I've just added essentially an address for both these things in EdgeX. Some additional data setup we have to do before we start talking to this camera and getting data off of this camera. We have to set up what are called value descriptors. Now, value descriptor essentially is EdgeX's way of describing the data that it's going to either receive from a camera or some sort of device, and or how it's going to communicate data down to a particular device. In our case, we're wanting to set up things like a scan depth. So an addressable is a means of describing what is actually going to be sent back and forth between EdgeX and devices. And in this particular case, we're telling EdgeX that we can expect to receive something called a human count, or if you will, a people count from this particular type of device. And we give some parameters around that particular descriptor, giving an indication that the value in terms of this count will probably be in the range of 0 to 100, that it's an integer type. That's what that I stands for. We're calling this a count. In other words, we're establishing a label. So EdgeX has some context about what it is that it's seeing in terms of this information. All the particulars about this particular type of data that's going to be received from, in this case, our camera. So let's go ahead and post that in. We post value descriptors into core data, which is at address 48080 in terms of port numbers for EdgeX microservices. We post that in, and we get back again the GUID or an address for that particular service, from that particular service, in this case core data, and again a status code back of 200. So we've just created the first value descriptor describing the data coming from a service. Let's do one as well for canines. We've got human count. We're also going to do one for canine count, or what we call dog count, if you will. So I'll post that value descriptor in as well. And again, I get back an identifier for it. Lastly, we want to be able to eventually set the scan depth of our camera. Again, being able to actuate back down to the camera. So we're going to set what we call depth as a value descriptor, or something from a description we call a scan distance. Again, all the parameters set with regard to mins and max and defaults and types. Let's go ahead and post that as a new value descriptor inside of EdgeX. And that's a request that's made to core data. So now we've set up two addressables and three value descriptors, if you will. We set up some of the base data needed for EdgeX to understand the location of things, in this case the camera and the device service, and how to understand the data types associated with the data it's going to see coming from or to the camera. One other thing that we will do is that we're going to set up what's called a time or a duration value descriptor. And this is the time between events. We want to be able to suggest to EdgeX what's the time between, say, for example, the readings that might come off of a particular camera. So we'll make one more call here to value descriptor to add that duration capability in. And it is possible that the camera could come back with some sort of error as one of its responses instead of the human or dog count. So we'll set up that as a value descriptor. Any kind of information that's being exchanged between EdgeX and the devices needs to be represented by a value descriptor. So we'll also set up this camera error as well. Great, so now we're done defining essentially some of the data elements associated with how data traffics back and forth between EdgeX. We've set up the addresses. Now we're ready to actually establish the device inside of EdgeX. We do that by establishing what's known as a device profile. And there's an upload API to actually upload a device profile into EdgeX. Now, a device profile is actually a YAML file. Device profiles describe the device. What types of commands can be made of that device? What types of data should we see from that device? As the name profile suggests, it gives EdgeX all the information about what that device should, how that device should be communicated with, and what types of data and information should be coming out of that particular device. So we're going to upload the device profile for this particular device. And so let me go to my downloads here. And I've got a particular device profile already picked out. One, again, that was kind of manufactured just for this exercise. If I can find it there. Where is my camera device profile? There we go. Camera monitor profile. And I'll ask to post that new profile into metadata, where all profiles are stored in EdgeX. And again, once again, we see the ID coming back that suggests that EdgeX has received that profile. We get the status code 200. Now we can actually register the device service. That is, again, the service that's actually going to handle the requests coming back and forth between the device into EdgeX. The device service we're going to call the camera control device service, and this is what's going to actually manage, again, the human and dog counting cameras that we have out there. Now, we haven't created the device yet. We're going to set up the device service first. Notice a couple of things here. One of the things is that we're providing an indication of its particular admin state, which is unlocked, its operating state, which is enabled, and we're also providing the address pool. Remember, we created the address pool already for this camera service, and we said that was going to be the camera control. So in the address pool, we're providing an indication of the actual location of this device service by its name, in this case, camera control, which we already set up previously. So let's go ahead and post that into EdgeX. Again, we post that into metadata. Metadata needs to know where to reach this particular device service. And again, we get back an identifier and a status code 200. Now we have our device service set up. Finally, we are ready to set up our device inside of EdgeX. We've got our address pools, we've got our value descriptors, we've got our device service in place, we've got our device profile in place. So now we're ready to set up the actual device itself. So we need to make a call to the device API to post information about our device. We're going to call our device count camera 1, supposing that maybe sometime we're going to have camera 2, camera 3, and so on. And again, we provide things like our admin state and the operating state of this particular camera. And again, we provide an address pool. Notice again that this is camera 1 address, the exact name of the address we set up for the camera way back in one of our first setup calls. We provide some additional information. We provide information such as the device service that is actually managing this particular device, that which we just set up, the camera control device service. And we provide the profile information. Remember how I uploaded that camera monitor profile? Here we reference and connect all the dots. Here we're connecting the dots between the device service that manages that device, and the device profile, which specifies all the operations that can occur on that particular camera. So let's go ahead and make a post into EdgeX for the camera now. And now we've got our device, at least as far as EdgeX is concerned, up and running inside of it. Now, in reality, we don't really have a device out there, so all this has been made to post data into the EdgeX database, but presumably at this point, information from the camera could start spilling out and be seen inside of things like our core data. We'll see how to mimic that and how that would actually look in a real case, But in reality, we'll have to mimic that because there is no actual device or sensor that we have out there providing that data to us. Let's check now to see that all of this pre-work we did to set up the addressables, the value descriptors, to get the device and device service and the device profile all set up. Let's check to make sure that these are actually now available and been posted correctly into EdgeX. So with that, we're going to make some check calls. We're going to make some calls to the various microservices in EdgeX to check that the information is actually available inside of metadata and such. So the first one we're going to check on is to make sure that our device service got created correctly. So we're going to make a call into metadata at the device service API. We're making a get call here as opposed to a post or a put. We're making a get call to list out all the device services that EdgeX currently knows about. So I'll send that in, and now we'll take a look. Quite a bit of information comes back in terms of the, let me shrink my code here a little bit and move it up. We're going to get back JSON that indicates that it has this device service that knows about called the camera control device service. We see all the particulars about the information that we supply to it, things like the description. We got back its ID again, the fact that it's enabled in terms of its operating state. So all the information we supplied. In addition, it's addressable. Remember, we set up the addressable called camera control. Well, here are all the particulars of that addressable. Again, giving EdgeX an indication of where it's actually physically located in its port and things of that nature. But we know the device service is now in place inside of EdgeX and inside of EdgeX's metadata service. We can actually do other queries for information from that database about device services. For example, we could find device services where there's a label of camera. So you can actually perform all the APIs now of metadata that would give you back information of that device service as if you were some other third party or other application that needed that information. Let's check too about the device. Was that set up correctly? So we'll make another call of metadata and ask for all the devices that EdgeX knows about. And in this particular case, again, let me move that down a little here. We get information back about our count camera 1. Again, that it's the human and dog counting camera, all the information we provide to actually get our device set up, including its addressable. Again, where is it actually located at camera 1 address, including things like the service that it's associated with, the camera control device service, and including its profile, if I can find it. Here we go. Its profile, which again was the camera monitor profile. And the profile provides all sorts of information. Again, the types of commands that can be executed against that particular device, and what types of data we can get back from the device. In this case, getting and setting things like scan depth, and getting and setting things like the counts from the humans and dogs, or the snap duration. Whoops, didn't mean to click on that, but you get the idea. Okay, so we've checked on device services, we've checked on devices. Lastly, let's check to see that EdgeX actually has the profile, the camera monitor profile in place as well. We'll make a get call on that. And actually, this is the same data we just saw associated with the device. We've just asked now directly for the device profile. But again, all the information about how to communicate with and get information back from or to this particular camera. With that, folks, we're now ready to actually exercise the API to command the actual device service and to start seeing data flow through from the Mimic camera up into things like core data and out through our export services. So first off, let's go ahead and make some command calls to our newfound device that's associated to EdgeX, our camera. First thing we want to do is actually list the commands we can actually execute on the camera. So I'm going to make it a get call to the command service, which is at 48082, and ask for all the device commands that can be or that are associated with the count camera 1. I don't want to know about all the devices. I just want to know commands I can issue to the count camera. So let's do that. And when I get back, and this takes a few seconds for it to execute, but once I've done that, what I've got back now is information. Really, this information came through by way of device profile, came through the metadata service by way of device profile, indicating the types of things that we can now call on our fake camera. In this case, we could call on to get people count. We could call on to get dog count. We could also do things like, if I can get it here, find the scan depth or set the scan depth. So one call is to get the scan depth. Another call is to set the scan depth. And in fact, the one we're interested in right now is to be able to actuate back down to the camera. So we're actually going to call to set the scan depth. So we're going to need this URL that command service provides us about how to communicate directly down through the device service down to the camera to set the scan depth. And what it tells us is if we call this particular API and we pass in the correct parameters for the actual device itself, which is the device's API, device's ID, and the actual command ID here, we can actuate the setting of the scan depth. And what it tells us even further is in order to be able to set that scan depth, we need to be able to provide some information to it. We're going to need to actually provide a parameter to it called the actual depth. So as we post into this request, we need to provide a parameter called depth. Now I need to copy a couple of pieces of information off of here in order to be able to make this request in. I'm going to need to, and let me get a notepad up here. I'm going to make note of a couple of IDs that we're going to have to use. One of the IDs is the device ID, and the other ID is the command ID that we want to actuate. So I'm going to copy some information, and you'd have to do this too when you actually get to calling this API and walk through yourself. Oops, I just skipped it here. Let's copy that, and I'll copy that to Notepad here. And I'll remove the path variable there. So I've got the device ID and the command ID. Those are going to come in handy when I actually want to actuate the device in just a second. Okay, so we've seen how the commands come through this command API. By the way, too, just to kind of complete our exploration to make sure everything is all set up and being able to actuate and send information down to this camera, let's check on things like the value descriptors. Are they in place so when we communicate things like scan depth, EdgeX knows about it? So I'm going to get from our core data service all the value descriptors. Indeed, when I make that request, I see again the value descriptors for people count, dog count, scan distance, time between events, and our error response all come back as part of those value descriptors. So we know that the system is now set up right. Let's go ahead and actually start to go and get information sent down to this particular device. In this case, we want to issue a command to put the scan depth at a certain value. And in particular, let's set the scan depth to, say, 9, presumably something like, I don't know, 9 meters or something. Now, we're going to need a couple of parameters to go into this put call to the actual command for this device. We need the specific system device ID, and we need the command ID. And that's why I made that copy to Notepad for these two pieces of information. Now, in order to be able to actuate this in our Postman tool, I need to be actual to set those particular IDs in here. So I'll copy my device ID into the device ID variable, and I'll set my command ID into the command ID variable. Whoops. Did I get that? Yep. Okay. Update that. Close that. And now, hopefully, when I issue my command to set the depth on the camera, that'll get posted down to the actual device. Now, what happened when I did that? Well, guess what? We got a 502 bad gateway. Essentially, what did EdgeX tell us by this particular call? It said that it couldn't get to the actual device. Remember, it had the ID for the camera. It had the information about the address for the camera. When it actually made the call down there, it got a 502 bad error. Why did it get that? Well, as I mentioned, we're actually mimicking this device. The device doesn't actually sit at that address right now. It's not physically there. So EdgeX tried to make the HTTP call, and it failed, saying, hey, I can't get to that particular address. So we actually got back an expected result here. If the camera was actually there, we would have gotten back a result that suggested that the status was okay, and we would have gotten back a response that the scan depth was actually set. So in this mimic environment, we are seeing an appropriate response. It just is one that may not look all that good because we would have liked to really seen a camera do something. When you have a real device, you'll get actually to see that when a command is actually triggered to that device. Now, in fact, when you're looking at this, this brings up an opportunity to say, well, how would I know that this error really is what we expected? How do I know that the command service tried to launch and make a call to actuate the device and then it got back an error that it couldn't reach that device? Well, this brings in a great opportunity to actually look at the log service. So inside of EdgeX, we have a log service at port 48061. And in this particular point, I'm going to make a request of the log service to give me all of the log entries for the EdgeX core command service. And let's see if we can't find that error that it just got back from the command service and trying to make that actuation. When I make that call, it takes a little bit of time because it's got to go out. Uh-oh. We should have gotten the error back. One of those, what you should have seen. Let me ask for a few more errors. It might have been more recently.
Jim, are you running those California Docker containers where there was the bug in the logging?
Thank you very much. You're exactly right, Michael. We do have a bug in the California version of these, and that's why I'm not getting backlog entries. Thank you. Michael saves my day here. What we should have seen, ladies and gentlemen, is an indication here of the logs. We do have a bug right now in the California release of this code base, and so we're not seeing those log entries. But you get the idea. We do have an API where you can actually see the return from the log service that those errors are actually there, and the fact that the command service did try to reach the actual device but couldn't. Thanks, Michael. Okay, folks, so now we've actually seen how the provisioning of device services and device gets set up. We've seen the ability to command a particular device, although we don't get back results because that's not a real device. And we've seen how to check to make sure that everything in terms of setup has been done correctly. The one thing we haven't yet seen is how do we actually get data into core data as if it was coming from this device. Well, let's explore that here in this next part. So we want to actually pretend as if we are the device, and we're going to pretend as if we are the device of pushing up human and dog counts into core data in EdgeX. How do we do that? Well, there's an API that every device service calls to send data into EdgeX, and that's the event API. It's at 48080, which again is the core data address. And in particular, we're going to make a post call, and we're going to make a post call with a collection of JSON data here that represents the key value pairs that any device service reports into EdgeX as its data readings. And you'll notice that it specifies as part of this data what device it came from, in this case our count camera, and what it's reporting, its readings. In this case, that the human count we're sending in is 5, that it sees 5 people right now. And in terms of canines, it sees 3. Now again, we're mimicking this device, but in real world circumstances, this is exactly the type of JSON data that's pushed from a device service by device through device service up to core data. If you were actually sniffing the wires between all these services, this is the type of JSON that's actually sent and forwarded into core data, again with a post to the event API. Since we don't really have a device to do that, let's mimic this by actually issuing this post command as if we were the device service, the camera monitoring device service. So I'll make a call to send. And when we do that, we get back an identifier for the event that was created, and again, a status code of 200. Now, how do we know that core data actually received this data and received it and stored it into the Mongo database that's part of EdgeX's persistent store? Well, what we can do is actually ask core data now for the number of, or count of, if you will, events that it's actually received. Since this is a brand new system, what we should get back is 1. That we see the 1 reading that was posted into our core data system by our fake mimic of the camera device. If I was to go back and actually issue that same request again, let's change it. Let's say maybe instead of a 5 human count, that was 4, and dog count was say 2, and if I post that in, I get back another event ID, and if I go back to core data again and ask for the count, now my data, if I send it there, now my event reading count is 2. So we see it up every time I add a new reading, event and reading into core data. Now you might say, well, that's great. It actually is counting the number of events, but how do I know the actual data itself is there inside of core data and Mongo? Well, let's go ask for the last 10 camera readings from EdgeX, from core data. The API for that, again, at core data is event/device/the device name, in this case, count camera 1, and the number of readings that I want to get back, or I should say the number of events and the readings that I want to get back. So we get that request, and what do we see come back? Those 2 events that I posted from camera 1. And in the first instance, the human count 5 and the canine count 3. And in the second instance, of camera count posting human count 4 and canine count 2. So we're actually, again, seeing how data comes up from a device through a device service into core data. The exact same types of API calls that would be realized if you actually had a real device out there. We can actually simplify things even more. Instead of getting the events and the readings, I can ask for, well, just give me the readings. In this particular case, give me all of the human count readings, or the last 10 human count readings that are stored in EdgeX under core data right now. So if I post that request, I see again my human counts of 5 and 4. Remember, I didn't ask for dog counts, I just asked for the human count readings. So we can actually start to exercise the entire API out there on core data or any part of EdgeX to start to see what's happening with that data as it makes its way into EdgeX. Last part, ladies and gentlemen, let's go start to explore, well, how would I get this data off into some other system? How would I get it off to the cloud? How would I start to exercise the data with some sort of other local analytic capability? Well, for that, we would have to use a export client registration facility to register where you want the data sent to. And it just so happens that by default, our own rules engine is registered as one of those clients. So if we take a look at 48071, which is the export client port, and if I ask for all registrations that the EdgeX export client knows about right now, I would actually see that there's already one pre-registered client of all data coming through EdgeX, and that's our rules engine. That allows our rules engine to monitor and see the data coming through, and if we put in particular rules, we'd actually see it fire commands and do work out there itself. So rules engine by default is already a recipient of all data that comes into EdgeX. But what if I wanted to set up another client? What if I wanted to send a client, for example, and send the data off to something like a MQTT broker? Well, then I would have to register that particular client through the registration API. So rather than making a GET call, I'll make a POST call to registration. And I would use a JSON string like this to set up my particular addressable. In other words, where do I want the data to be sent? In this case, a cloud MQTT address. What's its port? What's its username and password? All the details in order to be able to access that particular MQTT topic. I would give information about what type of format I want the data to arrive in. Whether I want it in JSON or XML. Do I want it to be encrypted? Do I want it to be any way compressed? And I would also provide things like the actual topic that I want the data to be sent into this MQTT pipe for. All that information in the JSON. If I post that now, that'll give me back an indication again of a status code 200 and the ID of this new client. Now, any data that would be flowing through EdgeX would be also sent off to this new client, as well as to our rules engine. Both the rules engine and now this MQTT topic would serve as clients to receive all data coming through EdgeX. So with that simple API, we're able to start to see data not only inside of EdgeX, but you could actually see the data from being collected by sensors being seen now in some external source, some MQTT topic, an HTTP endpoint, Azure, Google, whatever the case might be. And there are examples in our documentation for how to set up all sorts of various clients to receive this data. With that, folks, we've gone ahead and gone through the API walkthrough. Let me bring back my slides here real quickly. Just about hit the time limit here, so we're doing well. The walkthrough, again, is available on our docs page, docs.edgexfoundry.org. Michael's done a great job of reorganizing and cleaning up that walkthrough, so hopefully you will find that's well organized and follows along the path and the trajectory we actually went through with this tutorial today. If you're interested, all those API calls are specified in that document, but I also pre-entered them in a Postman API set that you can actually download from this particular address, bit.ly EdgeX API walkthrough. It'll give you a collection that you can upload in your own Postman tool. It even includes the environment you need. Now you'll have to set your own environmental variables there, like I did as I was demonstrating the walkthrough, where your host is, the name of your device ID, the command ID, things of that nature. But it gives you all the same capability to actually run through this walkthrough on your own without having to enter in all of those API calls and make a mistake and try and figure out what happened. The APIs there should all work with regard to the current implementation, with the exception of logging, as we saw. Again, this bit.ly address will give you that API set to run in Postman. It's also available at this address. That bit.ly address just points you to this getpostman.com site where I've got the prearranged set of APIs already established. Upcoming Tech Talks. Hopefully you found this Tech Talk today on the API walkthrough beneficial. Hopefully you'll use it as you do your own API walkthrough. We've got some upcoming Tech Talks we want to provide on things like device services, provide a tutorial on how to get new device services set up, export client, how you actually do some of the export work that I showed you a little bit about, the registration and things like Rules Engine and an MQTT topic. We'll give you more details on that coming up soon. Email either Michael or myself, or provide a Rocket Chat comment, or send in through the EdgeX email forums any suggestions you have about Tech Talks you'd like to see coming up in the future. We would love to be able to facilitate your needs and provide something that is of use and value to you. With that, we've got a few minutes to take any kind of questions. Michael's posted his email there in the group chat, but as well, use the chat window if you do not want to speak up on the microphone. Use the chat window to post your questions. Got a couple minutes. Questions on the API or anything EdgeX related.
And I've also posted a link to the wiki page where we list the information about our Tech Talks. So any future Tech Talks we'll list there with their day and time. And also, as soon as this recording is available for watching, we will update the link to that so that you can rewatch it or share it with anybody else in your company who you think might be interested in watching this.
Thanks, Michael. Thanks, everybody.
All right. And if there are no questions, hang on a second.
The joy of phones.
We will be taking October off for these Tech Talks because we have a couple of big events coming up for us. We will be at IoT World Software World Congress in Barcelona, and then we will be at the Embedded Linux Conference in Edinburgh, Scotland. So in November, we should pick these up again. And again, keep an eye on that wiki page. We will post the new schedules there as they come on, and I will try and send reminders out to the EdgeX Devel mailing list and also post it to the Rocket Chat the day of. Okay, so Telemac has a question in the chat. They're asking, what scale is Edge? I'm assuming he means is EdgeX made for. So what kind of deployment are we targeting?
Yeah, thanks, Telemac. And the answer there is it depends. And that's a really bad answer, I know. But EdgeX is meant to address all sorts of different types of devices at different rates of reading. And I'm assuming when you talk about scale, how many devices can I hook up to it and how much data can I have come through EdgeX? And that really depends on your use case. If you have 1,000 sensors, but each sensor is only sending in, say, one reading per every minute, well, EdgeX can consume a lot of that data. One instance of EdgeX could easily handle that entire mass collection of 1,000 sensors, one reading a minute without any problem. If you're talking about one sensor, but it's sending out data at, say, once every microsecond, wow, that's a lot of data even from one sensor. So it really is dependent on the number of sensors and the amount of collection or frequency of collection per that particular type of sensor set that you have connected. So one of the things we've done with EdgeX is we've designed it so that you could have multiple instances, right? You scale horizontally. You determine based on your use case and the frequency of data you're collecting, essentially how many devices you need to hook up per instance and what the data flow is. And then you associate any number of devices and their particular frequency to an instance of EdgeX, and instances of EdgeX might stack on top of each other. In other words, the export of one instance of EdgeX would be actually the device service to another instance as you filter it and try to compress it all the way up the line to get it to your cloud or your enterprise. So in that sense, EdgeX is meant to be extremely scalable It's just a matter of how many instances you need, all based on your use case, your frequency of data, how many types of devices you've got connected to a particular instance, things of that nature.
And you'll notice that in these examples, even though Jim had them all running on the same host, they all talk to each other based on host and port. So you can spread these services out across multiple devices, even if you needed to. So you could have some that are closer to the actual physical devices to be able to process that input faster, and then push that up to a beefier box that can do more of the processing on it.
Great point. Thanks, Michael. And I see a question from Henry. Is there some sort of installer that gets Docker and EdgeX installed in one step? Unfortunately, today, Henry, we don't have that. We have kind of your role is to get Docker and Docker Compose set up on your system. In some cases, based on your environment, Docker and Docker Compose get installed in one step. Then, with a Docker Compose file that we provide, in one step, we can have EdgeX be pulled down from Docker Hub and up and running all with one command. And I encourage you to take a look at our last Tech Talk if you're curious about how that's done, or if you're not sure about how to use Docker Compose to get EdgeX up and running in one fell swoop with one command after you get Docker and Docker Compose up. That's the one thing today that EdgeX doesn't do, is help to install Docker or Docker Compose.
And Docker isn't even a strict requirement for EdgeX. You can deploy it through other methods. We've got some people in the project who are building a Snap package to run on Ubuntu Core or other Linux systems that support Snap. Or you could just run the code directly on whatever hardware you have.
Great point. Yep, Michael. And by the way, too, anybody who's listening, we welcome contributors to help us with these kind of problems. So if you've got ideas about how you could maybe get EdgeX and Docker all installed in one fell swoop, provide us an example. And if you've got some code you think you could share with the community, great. At the very least, maybe a blog post, and that would be helpful to people as well if you've got some tools or things you think could help satisfy that kind of requirement. Other questions? On Telemac, I see Encil may be, I'm not sure what that means. Maybe you're suggesting that Encil would be a tool that could help with that. If that's the case, then Henry, you might want to take a look at that. Or Ansible, there we go. That makes more sense. Thanks, Telemac.
All right, well, we are almost out of time, so if there aren't any last-minute questions, we will go ahead and wrap this up. And again, we'll make this recording available just as soon as it is done being processed by Zoom, so keep an eye out on that wiki page. All right, and thank you, Jim, for the presentation once again. And we will be back with more Tech Talks after our Delhi release in November. So we will see you all then. Thank you.